Hey there, sixth grade. You're on page 162, number 3. STEM, a Rube Goldberg machine consists of a series of devices that perform a simple task. Kate is drawing a scale model of her Rube Goldberg machine, which she plans to build and enter into a contest. A bicycle wheel on the scale model is 2 inches in diameter. The diameter of a circle is all the way across the center, while the actual machine, it will be 28 inches in diameter. So we've got the model and the actual. Based on the measures of the wheel diameter, what is the unit rate of inches of machine per inch of the model? Okay, so you've got the actual machine, which is 28 inches to the 2 inches of the model, and they're both even, right? So for sure we can simplify it by dividing both of those numbers by 2, and we have a ratio of 14 to 1, which gives us a unit rate of 14 inches. It says unit rate, 14 inches of machine per inch of the model. Oh dear, I'm gonna type this. Of machine per inch of model. Okay, and what would the actual length of a rope that is 7.25 inches long in the model? What would be the, oh, did I read that wrong? What would be the actual length of a rope that is 7.25 inches long in the model? Okay, so we've got 7.25. We're going to take that times the 14 ratio. I'm just going to pull up my calculator here. One new thing, I will let you use calculators. You do have to show me what you are doing, though. That's the catch. So you have to show me, like, this is what I'm going to enter into the calculator, and then I will actually allow you to be doing that. All right, 7.25 times 14 gives us 101.5. So I'm going to type that in here too. Oh, my typing here is way better. I believe inches, right? Would be the actual length of a rope, 101.5 inches. All right, I'm going to clear everything. Chen bought a 20-foot chain for $36.50. What is the unit rate of price per foot? Okay, so again, I'm going to let you use a calculator, but here's the catch. You have to show me what you're doing. Okay, so you do have to write down what you're doing. To get this down to per foot, you need to get from 20 down to the 1 foot. How do you do that? Divide by 20. How do you figure out the price per foot? Well, divide it by the same thing. You guys know what to do. Oh boy, divide by 20. Okay. So again, you start with 36.50, divide by 20. And I know that you guys know how to divide it out. If I felt nervous about your abilities to actually divide and everything, I would have us keep practicing that. But there's some beauty in using a calculator and having that repetition in your brain, and you start to memorize some fractions and things. Then it says round to the nearest cent. As you know, we don't go to the thousandth of a cent, thank goodness, because that's kind of complicated. So we look at the hundredths place. What is the digit behind us telling to do? Well, it's half or more, so we're going to raise that score. So to the nearest cent, it is 183 per foot. Okay, at this rate, so notice we have to have this one correct to get the next problem correct. The good news is when you show your work and I know what happened, I won't count it wrong, right? I won't just be like, oh no, this number was wrong, so everything is wrong. I would give you grace on that and partial credit. So at this rate, what is the price of a 30-foot chain? Again, if I was really worried, if I were really worried about you, I would not allow this, but we've got 30 feet times that 183. Punch it in. Show me what you did though. 30 times 1.83, and that equals, we've got a label on here still. Go to the nearest cent, it's 9/10, so it would be not 9 cents, but 90 cents. Okay, 54.90. Number 5, a pool is being drained by a pump at a rate of 4 gallons per minute. An identical pump is added to help drain the pool. How does the second pump affect the rate of the drainage? This one is kind of interesting. So you've got one pump emptying a rate of 4 gallons a minute. If they put another one in there that's the exact same thing, rather than just tackling 4 gallons a minute, that second pump doubles what's happening, right? So the rate changes to 8 gallons per minute. We're going to say a second pump at the same rate doubles, how do we say it? Doubles the amount drained. Number 6, Melanie and her cousin Grace are arguing about who is the faster swimmer. So if they're faster, their time is shorter, right? The distance each can swim in a certain number of minutes is shown in the photo. How fast does Melanie swim? Okay, again, as long as you're setting it up correctly, so you've got 300 meters in 5 minutes. To get it down per minute, you've got that 300 and you need to divide. I would do the normal division sign, but it's tricky while typing. Divide that by 5. You can actually do this one in your head. 30 divided by 5 is 6. You've got the 0 there. So she's got 60 meters per minute. If you want to write the word per, that's fine. How fast does Grace swim? I'm going to opt for a calculator here. 325. Divide that by 5.5 to get that down to per minute. It looks like 59.09. If you look at the rest of this here, there's a 0 behind the 9. So I'm not going to bump it up. I'm just going to put 59.09. I believe that's also meters per minute. Double check here. Yes. If you wanted to go to the 10th place, we'd say 1/10. Who is the faster swimmer? Oh my goodness. They're essentially just 1 minute meter, excuse me. They're essentially 1 meter off. So, oh, you guys, I was focused on their time and not their distance. Okay, so if they're faster, they're covering a greater distance in the same amount of time. Sorry, you guys, I was thinking it was going to go by minutes for us and see like whose speed was shorter, which would make them the faster swimmer. But here they're covering distance. So that's, that I'm so glad I caught that. That's where labels matter so much. So Melanie swims a teeny bit farther, 1 meter farther than Grace in the same amount of time. So that makes Melanie the faster swimmer. Page 163. Mr. Sen wants to treat a group of friends either to the movies or to a hockey game for his birthday. Both the theater and the hockey team offer group pricing as shown on the table, which offers the lesser price per person, the movies or the hockey game. Again, I'm going to let you use a calculator. You are the luckiest ducks of 6th grade because this has never happened before in the history of 6th grade. So for the movies, to get the price down per person, you don't divide by the money because you're not figuring out $1. You're figuring out what the cost is per person. So we're going to start with $54.25 and divide that by the 7 people. Let me pull up my handy dandy calculator here. Divide by 7. Looks like $7.75 a person equals 7.75. And if you want to put per person, that's just fine. The hockey game, we've got the price, and you're dividing up the price. You're not dividing the people, dividing the price by those 12 people. Mommy. Hi, Nathan. I'm doing math right now. Can you give me just a moment? Divide that by 12. You made a fence. All right. Okay, hold on. Okay, give me just a minute and then I can focus on you. So we have $7 whole, and again, that is not 9 cents. That is 9 in the 10th place, which makes it a dime. That's 90 cents. Oh no. So label it $7.90 per person. Which is the better price? The lower cost is the better price. So the movie is the better deal. Or cheaper price for Mr. Sen. Number 8, Jan takes 9 hours to paint 2 desk sets. At this rate, how long will it take her to paint 15? Okay, Same spiel, you guys. I'm gonna let you use a calculator, but you have to show me what you're doing. So how long is it taking her? We want to figure this out per hour, right? So you've got 9 hours divided by 9 to get down to 1 hour. You have 2 hours divided by 9 will give you the rate per desk. I don't know what 2 divided by 9 is off the top of my head, so I need to work it out. 2 divided by 9 is 0.22. Oh boy. So 0.22 per desk. And you're going to take that, give myself some space here, 0.22 per desk, take that times the 15 desks. I'm going to clear this out here, 0.22, oops. It helps if you can use a calculator correctly. I just made that 0, that wouldn't work. So I did that wrong. That doesn't make sense. Takes her 9 hours to paint 2 desks. How long is it going to take her to do almost twice as many desks? Or 7, oh my word, 7 times as many desks. It's not going to take her. Okay, let me clear this.